It is one of the Navy's largest and most controversial ships, born from a commercial oil tanker design and labeled by critics as an easy target. Despite its immense size and vital mission, some say it is dangerously exposed in modern conflict. If the Navy knew the risks, why did they build it this way? The answer reveals a high-stakes gamble that few outside the Pentagon truly understand. The phrase easy target has followed expeditionary sea bases since their earliest days, surfacing in defense circles, op-eds, and heated debates in Washington. Critics point to their massive size, stretching nearly the length of 3 football fields, and their slow, steady pace, which rarely exceeds 15 knots. In a world where satellites sweep the oceans and radar tracks vessels across continents, a ship this large and this slow stands out. It is visible, predictable, and in the eyes of skeptics, exposed. Analysts raise alarms about the ship's defensive limitations. Unlike destroyers bristling with missile launchers and advanced radar, expeditionary sea bases carry only basic self-defense weapons, small-caliber machine guns, and little else. They lack armored hulls, compartmentalized interiors, and automated damage control systems that define true warships. Instead, the design borrows heavily from commercial oil tankers, prioritizing cost and cargo space over battlefield resilience. Public reports and think tank studies question how these ships would hold up under missile attack or drone swarm. In recent years, the threat environment has grown more complex, with adversaries fielding precision-guided weapons that can strike from hundreds of miles away. The Expeditionary Sea Base silhouette, easy to spot and hard to miss, becomes a symbol for everything critics fear about deploying ships derived from commercial designs into contested waters. This perception is not just technical, it is emotional. For some, the ship embodies a gamble, trading survivability for savings and risking a high-profile loss in the next conflict. That label, easy target, is not just about steel and speed. It is about trust, strategy, and the willingness to accept risk in the name of operational reach. Turning a commercial oil tanker into a forward-deployed sea base began as a problem of resources, not ambition. The Navy's program manager, facing tight budgets and rising operational demands, looked beyond traditional warship designs. The Alaska-class crude oil carrier, with its massive hull and proven reliability, offered a practical foundation. Shipyard engineers at General Dynamics NASSCO studied the Alaska-class lines, recognizing that its 785 feet length and wide beam could host both a sprawling flight deck and modular mission spaces. By using commercial diesel-electric propulsion, the team kept costs in check, approximately $500 to $600 million per ship, a fraction of what a new amphibious assault ship would require. Commercial construction methods dominated the build process. Instead of the heavy compartmentation and armored bulkheads found in combatants, the Expeditionary Sea Base interior remained open and adaptable, echoing the original tanker layout. Engineers installed a 52,000 square foot flight deck and reinforced mission bays, but avoided costly military-grade modifications. The result was a ship built for flexibility, able to support helicopters, special operations teams, and mine countermeasure gear, all while staying within budget. The approach was deliberate. The Navy accepted commercial standards to deliver persistent presence overseas, even if it meant foregoing the hardened features of a frontline warship. For the Navy, this was less about building a fortress at sea and more about creating a platform that could do the job, affordably and at scale. Steel plates stretched nearly 800 feet from bow to stern, forming a hull as long as an aircraft carrier and wider than most city streets. Fully loaded, an Expeditionary Sea Base displaces close to 90,000 tons, more than the weight of a Nimitz-class carrier. The flight deck alone covers 52,000 square feet, with space for 4 helicopters to operate at once. This broad expanse supports rotary wing aircraft ranging from the heavy-lift MH-53E to the versatile MV-22 Osprey, giving the ship the ability to launch and recover multiple missions side by side. Below the flight deck, a mission bay offers another 25,000 square feet of configurable space. Containers can be swapped in and out for command centers, medical facilities, or special operations gear. The open architecture allows the ship to shift roles without returning to the shipyard, adapting to missions from mine countermeasures to disaster relief. That mission flexibility is intentional. Living quarters and workspaces accommodate around 250 embarked personnel. The ship is built for endurance, with berthing, messing, and workspaces designed to keep crews operational for months at a time. Nearly 500,000 gallons of fuel are stored in tanks below, powering the ship's engines and generators and refueling helicopters and smaller vessels at sea. Every dimension, length, displacement, deck area, personnel, fuel, reflects a platform engineered for persistence. It is not just a floating base, but a node for sustained operations, able to support aviation, logistics, and command functions far from shore. The scale and flexibility are deliberate, offering a kind of staying power that few other ships can match. USS Lewis B. Puller's journey began not with fanfare, but with a budget line and a pressing operational need. At a time when new amphibious ships were topping $2 billion apiece, Puller's price tag of between $500 million and $600 million stood out. The Navy's gamble was clear: build more ships for less, even if it meant accepting commercial standards over hardened warship features. That decision would soon face its first real test far from American shores. Commissioned in Bahrain in August 2017, Puller became the first United States warship to receive its colors overseas. The choice of Bahrain was no accident. The region demanded constant mine countermeasures, aviation support, and logistics, missions that did not require a full arsenal, but did require a platform that could stay on station for months. Puller replaced the aging USS Ponce, stepping into a role that had become central to United States operations in the Persian Gulf. In the years that followed, Puller's record offered proof of concept. By 2020, the ship had supported operations involving 9 different types of aircraft and unmanned systems, working with both United States and coalition partners. More than 1,200 launches and recoveries were recorded during a single deployment. Each sortie, whether a heavy-lift helicopter for mine clearance or a tilt rotor for rapid resupply, reinforced the logic behind the Navy's investment. The numbers tell their own story. For a fraction of the cost of a traditional amphibious ship, Puller delivered persistent presence and operational flexibility in a region where both are always in demand. The ship's commercial heritage did not limit its utility, it enabled it. In the calculus of modern naval operations, the trade-off paid dividends not in armor, but in sustained, adaptable performance. A ship the size of an Expeditionary Sea Base leaves a digital footprint that is almost impossible to hide. Satellites sweep the Red Sea and the Gulf of Aden, tracking vessels as they crawl along at 15 knots. Synthetic aperture radar, commercial imaging, and unmanned aerial systems feed a constant stream of data to anyone with access, state actors and non-state groups alike. In this environment, a ship's slow, predictable course becomes a liability. Analysts warn that a vessel's position can be triangulated in near real time, making it vulnerable to targeting by anti-ship missiles or explosive drones. The ESB defensive suite is limited to crew-served machine guns, offering little protection against modern threats that arrive at supersonic speeds or in coordinated swarms. In January 2024, Houthi sources claimed an attack on a large U.S. support ship in the region. U.S. officials quickly denied any successful strike, but the episode underscored the tension. In a contested zone, even rumors of an attack can fuel concerns about the risks these ships face. Protection for expeditionary sea bases relies on the company they keep. Navy doctrine calls for these ships to operate within task groups, shielded by destroyers, aircraft, and coalition partners. Escort vessels bring layered defense. Radars scan the horizon, missile batteries stand ready, and air cover patrols overhead. In this framework, the Expeditionary Sea Base is rarely left alone. Its vulnerability on paper is offset by the force that surrounds it, turning a so-called easy target into a well-guarded asset. Flexibility is built into the ship itself. The mission deck can be loaded with containerized modules, command centers, medical bays, or even advanced weapon systems. This modular design supports expeditionary advanced base operations, allowing the ship to adapt for logistics, aviation, or strike missions as needed. Survivability in practice comes from dispersing risk across the fleet and tailoring each deployment to the mission at hand. The Navy's strategy is not to harden a single ship, but to make the entire formation resilient, connected, and ready to respond. Today, as the Navy faces rising threats and shrinking budgets, the Expeditionary Sea Base stands as a calculated risk, delivering global reach at a fraction of traditional costs. In an era defined by trade-offs, vulnerability is not just a flaw, it is a deliberate choice. The real test will come when strategy meets reality.